Hi everyone, good afternoon, welcome back my dear friends. Quickly join. How are you all? A very good afternoon. We are going to today complete Newton laws of motion and work power energy using some of the most important numericals. We are going to complete these two chapters. Quickly let me know in the chat box if I am clearly audible and visible. Hi, good afternoon Robin. Hi Sanjana. Hi Rakshita, Mahalakshmi. Hello. Good afternoon. Welcome back. Quickly join. How are you all? Everything's good? All right. So, using these PYQs of, I've got a mix of some of the questions are from JEE mains, some of the questions are from modules, right, from different books. Let me tell you, if you are going to do these many questions with me, it will be more than sufficient. That means your Newton laws of motion and work power energy will be almost over, and then you can proceed with mock exams, right? So please note that we are going to almost 90% of the topics are going to be covered by these important questions. Other than this, you need to revise again, you need to revise your notes, you need to attempt more mock exam, and that will be sufficient for these two topics. All right, great. So let's quickly start without any delay. Let's start with the first question. My dear friends, first question is somewhat like this. And see, questions are going to be of, you know it, questions are going to be of slightly difficult level. At least some of the questions are going to be difficult. So do not worry, attempt it, give your best attempt. After your attempt, I am going to explain, right? So the first question says, a modern Grand Prix racing car of mass m is traveling on a flat track in a circular arc of radius capital R with a speed v. If the coefficient of static friction between the tires and the track is mu s, then the magnitude of the negative lift acting downwards on the car is. Assume forces on 4 tires are identical and small g is equals to acceleration due to gravity, right? So everyone knows circular turnings of car, that means banking of road. This is a question related with that, right? Let's attempt it. It's a new type of a problem. Be quick. Hopefully I am not covering the question, you can see it properly. Let's begin. Let's try it. While you are trying, I am also going to give you some tips, right? So tip for this question is, always draw free body diagram. That will help you. Come on, be a little quick my dear friends. Let's suppose we have got a car over here. I can also draw a circular track for you. Let's suppose this is the circular track. And let's say, my dear friends, this is the top view of the car. Fine, clear? And let's draw the free body diagram of this car. So we are going to have friction over here. We are going to have centrifugal force, which is basically mv square by r. Over here we have got friction force over here, which is mu into n, right? And then downwards mg is acting. So please note, my dear friends, that this mg is acting downwards. This mg is acting downwards. This mg is acting downwards, right? Let me explain it to you. So let's suppose if this is a car, then friction force is acting in this direction, centrifugal force is acting in this direction, mg is acting like this, got it? Mg is acting like this, and a downward lift is also acting. Something like this. Clear? So a downward lift is also acting. Fine, let's draw a downward lift. Let's call it as FL, and then we have got a normal reaction which is acting upwards. Something like this. All right, clear? I've drawn the diagram for you. Let me know in the chat box. Hopefully you don't have any doubt in this free body diagram. If you have any doubt, let me explain the concept also after solving this question. Be a little quick. Let's quickly solve it, my dear friends. And after this, we are going to talk about circular turnings again. Now let me explain this question to you. First of all, this free body diagram is drawn with respect to the body. That is why always we are talking about centrifugal force. Centrifugal force is basically a fictitious force. We draw centrifugal force whenever we are trying to draw free body diagram with respect to the body, right? And this is friction force, which is actually keeping the car on track. Clear? Now we all know, please see here, my dear friends, we all know that friction force must be greater than or equal to, that means the maximum value that we can write over here is mu n is equals to mv square by r, mv square by r. And instead of normal reaction, my dear friends, hopefully you guys can see that normal reaction will be mg plus fl is equals to mv square by r. And if I am going to rewrite it again, I am going to write mu mg plus mu fl is equals to mv square by r, and I am going to write minus mu mg like this, and then fl will become, let's take m common, so we are going to write v square by r, v square by mu into r minus g. So m times v square divided by mu r minus g, that means option A is absolutely correct. This is your answer. This is your answer, my dear friends. Do let me know in the chat box if you have any doubt. Alright, please understand. Acha, by the way, let me tell you what is this negative lift. What is this negative lift? Right? Got it? What is negative lift? You have seen racing cars. Do you know about spoilers, right? You know about spoilers. Let me draw a car for you. Here we have got spoilers like this, if you can understand, right? You have got spoilers like this. Now these spoilers actually act in exactly the opposite way how the wings of an aircraft works, right? Wings of an aircraft provides an upward lift. These spoilers provide a downward lift. So when they are talking about, they themselves have said that it is acting downwards. That means it is acting along mg, which means that normal reaction can be written as mg plus fl. mg plus fl. ऑलराइट, क्लियर? सर मैं बंगाली स्टूडेंट हूं, इंग्लिश अच्छा नहीं आता, क्या एनटीए बंगाली क्वेश्चन पेपर में ट्रांसलेशन गलत करेगा या पूरा लाइन ट्रांसलेट नहीं करेगा? There is a possibility that NTA can commit such blunders, right? We cannot expect a lot from NTA. I think we should not expect anything from NTA. So it can do such things that it can actually make mistakes in translation from one language to other language. Other than that, I think you have got English. I think you should stick with the English language, because mostly whenever you are going to learn from any book, from any faculty, they are also going to speak in, and at least the questions are going to be in English. Okay, so let's quickly move on, my dear friends. Hopefully the first question is all good. Let's move to the next problem. Let's see this one. Come on, be quick. I want your answers in the chat box. Okay, and if you have any doubt, do let me know. Robin, your answer is right for the last one. In this question, they are saying a block of mass m slides down an inclined plane inclined at an angle of 30 degree with an acceleration of g by 4. The value of coefficient of kinetic friction will be. What is the value of coefficient of kinetic friction. My dear friends, if you have any doubt, let me know. I'm going to explain the concepts also with numericals. Okay. So in this problem, my dear friends, they are saying you have got an inclined plane and it is inclined at an angle of 30 degree. It is inclined at an angle of 30 degree. And then they are saying that a block of mass m slides down. A block of mass m slides down with an acceleration of g by 4. With an acceleration of g by 4. And we have to find out the value of mu. Very good, very good. Let's quickly do it. Okay, so the acceleration is g by 4. Great. Let me draw the free body diagram. And motion on an inclined plane is a very, very important topic. So let me explain it to you. See, let's draw free body diagram of this body. It's very easy. You have got one force which is acting downwards, which is mg sine theta. You have got another force which is acting in upward direction, which is nothing but friction force, which is equals to mu into n. You have got a force acting downwards, which is mg cos theta, which basically means, my dear friends, you have got a normal reaction acting upward, acting along this direction, whose value is going to be equals to mg cos theta. All right. So now after this, they are saying that it is accelerating downwards. If it is accelerating downwards, that means definitely this force has greater magnitude than this force, obviously, right? And net acceleration will be written by something like this, my dear friends. Please see, g sine theta minus, instead of mu n, we are going to write mu g cos theta, and this should be actually equals to g by 2 as g by 4 as they have said. So we can cancel out g. Instead of sine 30, we are going to write 1 by 2. We have to find out the value of mu. Instead of cos 30, we are going to write root 3 by 2. And we are going to get 1 by 4. So this will become 2. This will become 2. Right? And after this, I think almost we have got our answer. We are going to get 1 by 2 and we are going to get mu. This is 1 by 2 minus 1 is 1 by 2, and you have got mu times root 3 by 2. So 2 and 2 gets cancelled out. Just a second, let me see. This 2 is also cancelling. This 2 is also getting cancelled out, of course. So we don't have any 2 over here, which gives our answer as, friends, mu is equals to 1 upon 2 root 3. 1 upon 2 root 3. Please check and let me know in the chat box. Very good. Very, very, very good. Great. Answer B is absolutely right. Answer B is absolutely right, my dear friends. Now let's move on. Clear? Any doubt? Sorted? Moving on to the next one, my dear friends. Let's see this question. Now let's increase the level of the question by a bit. In this question, they are saying, consider a block kept on an inclined plane, inclined at an angle of 45 degree as shown in the figure. If the force required to just push up the incline, kindly see, to just push up the incline is 2 times the force required to prevent it from sliding down, then the coefficient of friction is. Be a little quick, let's solve it. Be quick. Kindly understand the problem, what they are saying. Come on, Saksham, forget about Navya. Let's worry about friction, let's worry about NEET, let's worry about RE-NEET. Okay, instead of Navya, think about NEET. Okay, so in this question, the important condition is that we want to find out coefficient of friction such that the force required to push it up the incline is 2 times the force required just to prevent it from sliding down. Okay, great. Let's see. First of all, first of all, let's talk about what if it is going to slide down. Okay, sorry, let's talk about what is the force required just to prevent it from sliding down. Listen here, just to prevent it from sliding down. Clear? So that means you have got mg sine 45 acting downwards. That means, my dear friends, mg by root 2, and then you have got a minimum force should act in this direction, and by the way, you have got also friction force. So friction force is mu n, and n is, by the way, mg by root 2. Now kindly see, mu is always going to be less than 1. Clear? That means, friends, this value, let me explain the question. This value will always be less than this value. Why? Because mu is less than 1. Got it? So this force is less than this force. So we will have to apply a minimum force over here. We will have to apply a minimum force over here. We will have to apply a minimum force over here. Clear? Now, what is the value of this minimum force? So this minimum force will be, mg by root 2, minus mu mg by root 2. So I am going to take mg by root 2 common, so I will get this. This is the minimum force required. This is the minimum force required. Clear? Right? This is the minimum force required. Now, next case, they are saying that to push it up, let me draw another diagram for you so that everyone can understand. Alright, if you have already got your answer, then I'll suggest you to please have some patience. I'm going to quickly move on to the next one. This is our block. Now we want to push it up with a certain force. So let's say this is that force with which we want to push it up, right? And now in this case, my dear friends, mg sine theta is acting downwards. Also friction force is acting downwards. So mg by root 2, and now you guys know that this is going to be actually nothing but this is going to be your friction force Fl, and that will be mu mg by root 2. Hopefully this makes sense. That means force required to push it upwards is actually equals to mg by root 2 times, because mg by root 2 will be common, times 1 plus mu. And now they are saying that this force is 2 times this force. Let's quickly do this math. Very simple math, my dear friends. I am going to say that mg by root 2 1 plus mu is equals to 2 times of mg by root 2 into 1 minus mu. mg and mg can get cancelled out, root 2 and root 2 can get cancelled out. I have got 1 plus mu is equals to 2 minus 2 mu. That means I have got 3 mu is equals to 1. And my dear friends, that's it. We have got our answer. Mu will be equals to, kindly see, mu will be equals to 1 by 3. 1 by 3, that means answer is A, 0.33. Clear? Is everything fine? Be quick. Let me know in the chat box. Done and dusted? Clear? Ayushi, Soumya, Farzana, Robin, Sanjana, Sakshi. Be quick. Everything's done. Can we move on to the next one? This is a nice problem, right? Please understand how to draw, how to write down the friction force, how to draw the direction of friction force. Friction force will always resist the tendency of relative motion. What I am saying, relative motion, tendency of relative motion. If they were saying that it is about to slip, or we want to prevent it from sliding down, it means that friction should act upwards. It means that friction should act upwards to prevent it from sliding, right? But still, in this case, friction is not sufficient enough to prevent it from sliding, and that is why we will have to apply a minimum force. So minimum force will be applied in the upward direction. So first equation is all done. In the second equation, they are saying that we want to actually pull it upwards. So if you want to pull it upwards, that means relative motion is acting in such a way that block is moving upwards on the inclined plane, which means that friction force will act downwards. Clear? Done? Be quick. Let me know in the chat box. Moving on to the next one. Moving on to the next one, my dear friends. Everyone's attention over here. Next question is on the board. A block of mass 10 kg is kept on a rough inclined plane as shown in the figure. A force of 3 Newton is applied on the block. Okay. A force of 3 Newton is acting on the block, right? And then they are saying the coefficient of static friction between the plane and the block is 0.6. What should be the minimum value of force P such that the block does not move downward? Such that the block does not move downward. So you have to balance the forces. Be quick. Come on. Quickly solve this question. Quickly solve this question, my dear friends. 3 Newton is acting downwards. We can see that a force of 3 Newton is acting on the block. Coefficient of static friction is there, right? And what should be the value of P? Now please understand how they are framing the question. They are saying what should be the minimum value of force such that the block does not move downward. That means to prevent it from moving downwards, friction force will act in upward direction. Friction force will act in upward direction, my dear friends. Friction force will act in upward direction. Upward direction, mu mg sine 45 degree. That means this is 60, right? This is 60 root 2. This is 60 root 2. This is 60 root 2. This is 3 Newton. We have got one more force acting downwards, which is mg sine theta. Mg sine theta. Okay. Now let's just equate these two forces. That means force P plus 60 root 2 is equals to 3 Newton plus 100 root 2 plus 100 root 2. That means P will be equals to 3 plus 40 root 2. Okay. Now find the value of this. 1.41. Find the value of this. This is around going to be 32. What do you guys say? Be quick. So I have written sine 45 na, sine 45 1 by root 2, cos 45 1 by root 2. I have done exactly the same thing, buddy. Kindly see. Come on. Be quick. Be quick, dosto. This is going to be around 32 Newton. Okay. This is going to be around 32 Newton. Please remember root 2 is 1.414. Option B is incorrect. Ayushi ji, option B is incorrect. Option A is correct. If you have any doubt, do let me know. Alright, so by looking at your responses in the chat box, I am thinking that you guys are not getting what I have done. If that's so, please let me know. Is it clear? Gaurav, good. Gaurav saying yes, sir. Your one sir is sufficient. Sorted? Okay, great. Alright. Robin, any doubt? Okay, good. Ayushi, good. Farzana. Soumya, 32. Yes, 32 is correct answer. Let's move on, my dear friends. Hopefully everything is clear. See, why I am constantly giving you problems related with friction inclined plane, because if you are going to see the pattern of previous year NEET exam, they have constantly given problems related with friction in inclined plane. Okay, let me explain it again, but I am going to be a little quick. See Farzana. Farzana, they are saying that a 3 Newton force is acting. Okay. A force P is acting, we want to find out the value of force P, fine. But they are saying the condition is that find the value of P such that it does not move downward. it does not move downward. That means friction force should act upwards. Friction force will be mu mg cos theta. Mu mg 10 into 10 cos theta cos 45 1 by root 2. This is 60 by root 2. This is P. This is 3 Newton. This is mg sin theta. mg sin theta. That means 3 Newton plus this is equals to P plus this. So P plus this is equals to 3 plus this. That's it. You have to solve it. Okay. Now I'm moving on. Casual. Okay. Okay, fine. Let's move on to the next one, my dear friends. This question says the time taken by an object to slide down a 45-degree rough inclined plane is n times as it takes to slide down a perfectly smooth 45-degree inclined plane. The coefficient of kinetic friction between the object and the inclined plane is. You have to find out the value of mu. Be quick. Let's solve this question. Let's say this is a rough inclined plane. Coefficient of friction is mu. A block is sliding down, right? A block is sliding down. Let's say distance of this this inclined plane is S. Sorry, the length, and the length of this is also S. And in this, so kindly see. Okay, fine. This is 45 degree. This is also 45 degree. No problem. Let's quickly draw the forces. This is going to be mg sine 45. This is going to be mg mu mg cos 45. Got it? So if I'm going to talk about acceleration, right? Let me write it as mg sine 45, and this is going to be mu mg cos 45. All right. Next is, this is simply mg sine 45. And both of these are being released. So for this case, my dear friends, I'm going to write S is equals to half a t square. For this one, I'm going to write S equals to half a acceleration will be g sine 45. That means in this case, acceleration will be g sine 45 degree minus mu cos 45 degree, which basically means I can take, obviously you have got g also over here, you can take g by root 2 common and you will be left with 1 minus mu. So over here you have got g by root 2 and you have got 1 minus mu, and then they are saying this is taking n times, right? This is taking the, they are saying that rough inclined plane is n times as it takes. So that was taking t time. So this is taking n times. So n square t square. Let's equate these two equations. Let's equate these two equations, and if you have any doubt, do let me know. Do let me know, my dear friends. So if we are going to equate these two equations, we are going to get 1 upon 2 g upon root 2 1 minus mu into n square into t square is equals to, you have got 1 upon 2 root 2, you have got g and you have got t square. My dear friends, I can easily cancel out g and 2 root 2, I can cancel out t square. I am left with 1 minus mu, and they want us to find out the value of mu. Please remember, they want us to find out the value of mu. So I'm going to write 1 upon n square, and mu will be actually equals to 1 minus 1 upon n square. That means D is the correct answer. D is the correct answer. Very good. Very, very, very good. Good, everyone. Any more doubts? Clear? If you remember, they have asked a similar question in NEET 2025 also, right? And this question is from JEE Mains 2023. I have again and again said the same thing. If you guys are going to do sufficient number of problems from JEE Mains PYQ, see, these are perfectly of NEET level, right? And they are also slightly new and better, right? So we need to, we have already attempted all NEET PYQs. Most of them are easy. And we are going to still attempt NEET PYQs before NEET exam. Before 1 week, we are going to kill all the NEET PYQs. But right now, what we should do is we should actually increase our level by a bit. That's why we are solving questions like these. Now let's move on to the next problem, my dear friends. Okay. Okay. Now I think inclined plane is fine. Let's start with some questions on momentum. Momentum is also very important, right? Next question is saying, Gaurav, who yaar, let's study, my dear friend. 100 balls each of mass m moving with speed v simultaneously strike a wall normally and are reflected back with the same speed in time t seconds. The total force exerted by the balls on the wall is, this is an easy one. Let's start. I'm going to give you poll for this one. 60 seconds. Let's begin. Be quick, my dear friends. Be really quick. This is an easy one, so I've given it to you. Come on. Come on, come on, come on, come on, come on. Be quick. Momentum is important. Friction is important. Inclined plane is important. All right. Okay, good. Good, 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 good. Use Newton's second law. Force can be written as change in linear momentum divided by time taken, right? And because they are only talking about magnitude, we are also going to find out the magnitude only. You have got 100 balls and each ball has mass m and velocity v, and they are reflecting back with the same speed. So the change in momentum for each ball will be 2 mv. So for 100 balls, it will be 100 times 2 mv, right? And divided by time, which is t. So it is simply going to be 200 mv divided by t. So 200 mv divided by t, right? This was a very easy problem. Option B is correct. Very good. Great. Great, my dear friends. So if you guys are able to do this, then let's also solve this question. Let's solve this question, my dear friends. Be quick. This is also a typical type of a problem. They have asked this in JEE Mains 2023. A block of mass √3 kilogram is attached to a string whose other end is attached to the wall. An unknown force F is applied so that the string makes an angle 30 degree with the wall. The tension T in the string is. The tension T in the string is, let's start. 60 seconds is, I think, sufficient. Begin. Begin, 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 begin. Come on. I have given you poll. In the meantime, let me also draw the forces. This is mg, right? So I can actually directly draw mg over here. This is tension T. So this is going to be one component of tension. This is going to be another component of tension. Kindly see, if this is 30 degree, this is going to be 30 degree. If this is T, this is going to be T cos 30. This is going to be T sin 30. T cos 30 degree will be equals to √3 into G. G is 10. So √3 into 10. So first equation is T cos 30. Let me save some time. T cos 30 is equals to √3 multiplied by 10. √3 cancel. T is coming out to be 20 Newton. If they are asking us about tension, then our answer is over here. Yes, this is, and if they are going to talk about force also, then that would be T sin 30. t sine 30, that means 20 into 1 by 2 is going to be equals to F, that is 10 Newton. That is 10 Newton. Clear? So 20 is the correct answer. Option A. Very good, Robin, Gaurav, Shoaib, Neeta, Ayushi, Farzana, Sara, Soumya, good. Very, very good. Okay. Now let's increase the level by a bit again. So I'm giving you all types of problem. Please remember, whenever you are going to see an easier question on the board, I also want to complete the chapter using all sorts of numericals. Now this is a nice question. In this question they are saying, please see. And if you remember in NEET 2025, again they have asked a similar type of a question. Hello, a root 34-meter long ladder weighing 10 kg leans on a frictionless wall. Leans on a frictionless wall. So wall is frictionless, right? And it rests on a 3 meter away. It rests on a floor 3 meter away from the wall as shown in the figure. Fine. F and Fw are the reaction forces of the floor and the wall, then the ratio of these two is. It's a very nice problem. Let's start. Be quick. Let's begin, my dear friends. Be quick. Quick. See, let me tell you one thing. If you guys are giving me answers in 5 seconds, in 10 seconds, then there can be 2 or 3 possibilities, right? There can be 2 or 3 possibilities. First is that you have done this problem earlier and you remember the answer. You know that C is the correct answer. Second is you're seeing the question, you're opening the next tab, you're googling it, you're seeing that option C is correct, and then you're giving me answer. In any which way, why you are wasting your time? This is the time where you should practice a lot of questions. Even if you remember that C is the correct answer for this one, I don't want to know the correct answer. I want you to attempt it. I am here so that you can actually practice some of the questions with me. If you guys are simply using Chat GPT, you are using Google, you are using or you are simply remembering the answer from your memory, then I mean there are lots of things on YouTube, there are lots of things on internet. Why you are wasting your time over here? I don't want to know the correct answer. I want you to solve these questions with me. Okay? So please solve. Please solve. This is not a problem that you can actually solve in 5 seconds. Let's say this is our rod. Let's say, my dear friends, this is our rod. Okay. Let me now draw the free body diagram for this. Let's start with the usual suspects like mg. Okay, mg is acting downward. mg is acting downward. Done. Reaction by wall will act in this direction. There is no friction over here. There is no friction on this wall. This wall is smooth, my dear friends. This wall is smooth. So there is no friction. If there was friction, understand, if there was friction, then the tendency was to slip down, then friction would have acted in upward direction. But right now there is no friction. Over here, you have got a normal reaction by floor. So this is FF, right? They have not talked about whether this floor is rough or smooth. Sorry, whether this floor is rough or smooth. Now it makes no sense if you are going to say, sir, this floor is smooth. Why? Because then this force cannot be balanced. Clear? So this floor will have to be rough, and this is going to be friction force. This is going to be friction force, and I am saying that this is going to be rough. This is the free body diagram. All right, this is the free body diagram. Clear? Nay, fine, very good if you are not using Google. I'm not saying you're using Google, but in any which case you cannot find the answer for this question under 5 seconds. Right? If you can solve the question under 5 seconds, then I should be the one who should learn from you guys, not the other way around. Okay? Now please see. First of all, we are going to do two things. These types of questions, and let me tell you one more thing. We are using these questions to actually complete our chapter, right? When we are going to be 1 week, when there is going to be 1 week time for your NEET exam, at that point of time, I'm not going to do anything. I'm going to simply give you questions and questions. Right now, let's discuss everything related with these problems. Let's not jump to the next question as soon as we get to our answer. Okay. So, my dear friends, in these types of problem, the concept is that the rod is in equilibrium. These types of rods are in equilibrium. These types of rod are in equilibrium. And equilibrium basically means two things. Equilibrium basically means two things. First is net force will be equals to 0. Summation of all the forces along x, y and z axis are going to be 0. Second, net torque is going to be 0. Net torque is going to be 0. So let's first use this equation. Upward direction force is F, downward is only mg. That means F is equals to mg. This is Fw. This is F, and by the way, let me also write this thing as capital, right? Because they have used capital. So this is Fw. So this is going to be Fw equals to friction force F. Now let's do again one thing. Please remember that this complete length is root 34 meter. Root 34 meter. All right. And now let's talk about, this is about summation of net forces is equals to 0. Now let's write summation of net torque. So we are going to find out torque about this point. We are going to find net torque about this point, point O. So net torque about point O is 0. Yeah, it will be 0, right? So this distance is going to be root 34 by 2. And if this is mg, this is going to be mg. This is going to be mg cos theta. And by the way, this we can easily find out what this angle is going to be. If you want us to find out cos theta will be simply base divided by root 34, right? So we are going to write, first is mg cos theta multiplied by root 34 divided by 2, and then the opposite torque will be applied by this, and this is going to be something like this, my dear friends. And please know, whatever this angle is, we are going to have same this angle. So this is also theta, right? So this is going to be Fw sine theta. So this should be equals to Fw sine theta. Clear? Right? Hopefully everything is sorted. Now the most important thing in these types of problem is, after this you can find out Fw. You can find out Fw, right? Because see, sine theta will be, this side will be under root of 34 minus 3. That means this is going to be under root of 31. This is going to be under root of 31, right? So you can use this equation and you can write down mg. Mg is, this was 10 kg, so 100 into cos theta. So cos theta is 3 by root 34. 3 by root 34 times root 34 by 2 is equals to FW and times sine theta, and sine theta is root 30, sine theta is going to be, my dear friends, perpendicular upon hypotenuse. That means root 31 divided by root 34. So this gets cancels out, and this is why I was saying that please do not give your answer so quickly, right? Okay, got it? So this is what I was trying to say. Now please see, from here you can get to know FW. So FW is known, right? F is known. Hopefully this makes sense. If you can know FW, you can also know FF, right? And please understand, they are talking about FW and FF. Now I'll have to use some space over there. See, FF is actually a different kind of a force. FF is actually a different kind of a force, right? Let me tell you. Let's do one thing, my dear friends. Instead of writing it as FF, let's write it as normal reaction N for a moment. Let's write it as normal reaction N. Hopefully everywhere else is all sorted, right? And FF will be actually under root of normal reaction square plus F square. So the ratio will be, my dear friends, FW divided by FF. FW divided by FF will be, I think we have already found out FW. FW is going to be, we have found out FW, and FF is this. FW divided by under root of N square plus F square. This is how you are going to get to the correct answer, my dear friends. And then yes, correct answer is, I believe, for this one. Let me see what is the correct answer for this one. The correct answer is, I believe, A. The correct answer is, I believe, A. Yes. But you're going to have lots of calculation in these types of problems. So even if you know the correct answer, if you have solved it previously in some mock exam, do not skip it, solve it again. Solve these types of questions again, solve your FW from here, substitute in this equation, and then you are going to get to the correct answer. Got it? Hopefully this makes sense, my dear friends. Quickly let me know in the chat box if you have any doubt. And you guys have given me answer of this question in less than 5 seconds. Be quick. Find the correct answer. Moving on to the next one, my dear friends. Be quick. Clear? Two blocks A and B of masses 1 kg and 3 kg are kept on the table as shown in the figure. This question is also nice. Okay. Okay, let me explain the previous question again. Soumya, do you have any doubt in the previous question? You can ask your exact doubt, dear. You can write down your exact doubt, then I am going to come back to this question. Ask your exact doubt, dear. I'll come back. In this question, they are saying that we have got two blocks A and B. The coefficient of friction between A and B is 0.2. So coefficient of friction between A and B is 0.2. And coefficient of friction between B and surface is 0.2. So both of them are same. The maximum force F that can be applied on B horizontally so that the block A does not slide over block B is. Come on. Be quick. Be quick. Free body diagram. I'll explain the free body diagram. Okay, no problem. Let me explain the free body diagram again. See, free body diagram is very simple. You have got floor like this, you have got wall like this, and you have got a rod somewhat like this. Clear? Mg will act downwards? no doubt about it. There is a tendency of this rod to slip in this direction. So friction force will act in this direction. This is a normal reaction by the floor. By the floor. So that means that because of these two forces, there will be a reaction force. Got it? There will be a reaction force somewhat like this. Please understand this concept. This is the concept that we have done in friction. This is the reaction force. These are simply the two components of those reaction forces. Clear? And another reaction force will be drawn something like this. All right. So this is mg. This is normal reaction. This is reaction by wall. This is friction force, and this is your F floor. Hopefully now this makes sense. Clear? Your doubt is sorted. Can I move on to the next question? Can I move on to the next question? Is it all fine? Can I move on to the next one? Come on. Two blocks A and B. Now let's solve this particular problem. They are saying the maximum force F that can be applied on B horizontally so that the block A does not slide over the block B. Hopefully now the last question is all sorted. You have to find out the net force F so that you have to find out the maximum force F so that the block A does not slide over. Come on, let's start. Be quick. Be quick. In questions like this, hold on, let me explain it to you. Whenever you have got two block problems, right? First of all, understand what is the maximum acceleration of A. What is the maximum acceleration of A? What could be the maximum acceleration of A? Maximum acceleration of A will be in one way. When block B will move in the forward direction, friction force on block A will act in the forward direction. Now think about it. If you have any doubt, Soumya, Robin, if any student has any doubt, do let me know. Friction force will act in the forward direction, and this is going to be the maximum value will be mu, that is 0.2. Mass is 1 kilogram, so that means 10. So that means maximum force can be 2 Newton, which means that maximum acceleration of A block can be 2 divided by 1, that means 2 meter per second square. Please understand. This means that the maximum acceleration with which block A can move is 2 meter per second square. You are going to say, how sir? For a simple reason, because see, on block A there are no other forces other than friction. No other forces other than friction. So if block A has to move, it will move because of friction force. And maximum friction force can be mu mg, that means 2 Newton. So maximum acceleration will be 2 Newton divided by mass of A, that is 2 meter per second square. This means that this combined system of A plus B should move with a constant acceleration of 2 meter per second square and not more than this. Because if it will move more than this, then friction force cannot supply that much force. It cannot provide that much acceleration and it will start to slide. Got it? Now for A plus B, please understand we are going to draw a friction force in backward direction, and this is going to be mu, which is 0.2, into mass. Mass will be 1 kilogram and 3 kilogram, that is 4 kilogram multiplied by 10. So this is going to be 8 Newton. So what is this force? So that means F minus 8 is equals to total mass times total acceleration. That means F should be equals to 16 Newton. F should be equals to 16 Newton. That means option A is correct. Clear? Be quick. Let me know in the chat box if you have any doubt. Friends, be quick, friends, be quick. If you have any doubt, do let me know. Clear? Can we move on to the next one? All right, great. So this was combined bodies. Moving on to the next one. A body of mass 1000 kilogram is moving horizontally with a velocity of 6 meter per second. If 200 kilogram extra mass is added, the final velocity will be. Conservation of linear momentum. Conservation of linear momentum. Somebody is saying हुबली पर set available है क्या sir NEET coaching का? हुबली पर set available. I think you are trying to ask me about the mock exam in Hubli. Most probably yes. Most probably yes. You can check that in. You can check that on PW website. Okay, or you can call the Vidyapeeth Center for that. Sir, friction is backward due to floor. Yes, Sarah, because block was moving in this direction, so friction force will act in this direction. Block was moving in this direction, therefore friction force will act in always in a such a way that it will resist the tendency of relative motion. Clear? Now let's solve this problem. This is a simple problem of conservation of linear momentum. The question is saying that a body of mass 1000 kg was moving with a velocity of 6 meter per second, and another block of 200 kilogram was kept on it. 200 kilogram was kept on it. So we are going to simply say initial momentum is 1000 times 6, and finally it will become 1200 times V. In today's class, we are going to solve many complex problems of conservation of linear momentum and work energy theorem, because we have to complete work, power, energy also in today's class. So don't worry. This is a very easy problem. Okay. So this gets cancels out. This is 2. This is 5. Answer is going to be 5 meter per second. Answer is going to be 5 meter per second. See, if you guys are asking any doubt, please note that I am going to definitely explain that. I will explain. All right. Moving on to the next question. An object is thrown vertically upwards at its maximum height. Which of the following quantity becomes 0? At its maximum height, if an object is thrown horizontally upwards, then at the maximum height, its velocity will become 0 and its momentum will become 0. There will be potential energy, there will be acceleration, there will be force. Force will act mg, acceleration will be g downwards, and potential energy will be mgh at any height. Right? Any doubt from the last one? Let's see this question. This is again a nice problem. Nice problem, my dear friends. A balloon has mass of 10 gram in air. Okay. It has 10 gram of mass in air. The air escapes the balloon at a velocity of 4.5 centimeter per second. If the balloon shrinks in 5 seconds completely, then the average force acting on the balloon will be. Average force acting on the balloon will be in dyne, my dear friends. All right, dyne basically means gram centimeter square, centimeter per second square. Be quick, solve this question. Let's begin. Let's begin, my dear friends. Let's begin. You have got a balloon of mass 10 kg. You have average, you have to find out the average force. Come on. Quick. Be quick, then we are going to move on to the next one. Come on. You have to use, see, whenever they are going to talk about average force, please remember force will be written as dP by dt. dP by dt. And then they are saying that you have got a 10 gram, you have got a balloon like something like this, right? And let's say that air is escaping from this balloon. Air is escaping from this balloon such that its initial mass was 10 gram and air is escaping at a speed of 4.5 centimeter per second and it completely shrinks. That means its mass, that mass is of air, right? In air, its mass goes to 0 in 5 seconds. In 5 seconds, right? So in this dP by dt, we are going to write dmv by dt, and we are going to get v times dm by dt. Because they are talking about average, I am going to simply write this thing is given 4.5 and dm by dt is 10 gram of mass is changing in 5 seconds. So that means this is going to be 2 and answer will be 9 gram centimeter per second square or 9 dyne. Answer B is correct, my dear friends. Please note answer B is absolutely correct. Clear? Let me know in the chat box. This is a different problem because over here they have many times I have said this, that in these types of problems where you need to use V dm by dt in concepts like rocket propulsion, they actually give this value as, in question they somehow give this value as gram per second or kilogram per second, right? In this question they have not mentioned anything like that. Clear? Yes, yes, Sarah. Please understand this is a nice problem. If let's suppose in a problem they are saying that mass is decreasing at a rate of 2 gram per second. 2 gram per second, then instantly it will actually click to you that okay, definitely we will have to use this formula. But over here they are saying that initially it is 10 gram and then it shrinks in 5 seconds. It shrinks in 5 seconds, right? That means you will, and they are talking about average. So we, instead of dm by dt, we are going to write it as del m by del t. And for del m, we are going to simply write 10 gram. Change in mass is 10 gram in 5 seconds. That means 2 gram per second is the rate of change in mass. Clear? Can we move on, my dear friends? Be quick. Let me know in the chat box if you have any doubt. If you have any doubt, do let me know. Moving on to the next problem. Moving on to the next problem. Answer my question. Answer my question. Everything's clear? In this question, they are saying a bag is gently dropped on a conveyor belt. So you have got a conveyor belt like this. Right, you have got a conveyor belt somewhat like this, fine, and it is moving at a speed of 2 meter per second. It is moving at a speed of 2 meter per second. The coefficient of friction between the conveyor belt and the bag. So let's suppose we have got a bag over here. We have got a bag over here. And then they are saying the coefficient of friction between the conveyor belt and bag is 0.4. Initially, the black bag slips on the belt before it stops due to friction. The distance traveled by the bag on the belt during slipping motion is. Nice problem. Let's start. Be quick. Be quick. Let's solve this question. You have to find out the distance traveled by the bag on the belt during this slipping motion. All right. Kindly start, and when it is gently dropped, okay, so if it is gently dropped, that means at this point initial velocity is 0. Initial velocity is 0 meter per second. Initial velocity is 0 meter per second. Be quick. Come on, I'm going to start poll for this. 90 seconds, let's start. Come on. See, what do you mean by slipping? Slipping basically means that you have kept this block on the surface. Now friction force is acting on it, right? And friction force is acting, this surface is going in this surface, my dear friends, this surface is moving in forward direction. That means with respect to this surface, this block is moving in backward direction, which means that friction force on this block will act in forward direction. Friction force on this block will act in forward direction. And if friction force will act in forward direction, we are going to write it as mu times mg, and I believe mu is 0.4 and mass is, my dear friends, we don't require mass. You know what? We don't require mass. Let's find out acceleration. So acceleration will be simply mu into g. So mu is 0.4 times 10, that is 4 meter per second square. 4 meter per second square, right? Please understand. Now we are going to use the first equation. V is equals to U plus AT. Let's keep V equals to 2 meter per second. V equals to 2 meter per second. U is 0. Acceleration is 4 and multiplied by T. So T will be actually 1 by 2 meter. 1 by 2 seconds. So in 1 by 2 second, my dear friends, this block will acquire a velocity of 2 meter per second. In 1 by 2 second, the block will acquire a velocity of 2 meter per second, and after that time, there will be no relative motion. After this time, after 1 by 2 second, the block will acquire a velocity of 2 meter per second and relative motion will cease. Relative motion will cease, and if there is no relative motion, then no friction is required, and then there will be no slipping. Clear? So we have to find out this displacement. So S is equals to ut plus half A, acceleration is 4, and T square. So this gets cancels out and answer is going to be 0.5 meter. So 0.5 meter. Let me know if you have any doubt. Be quick. Done? Any more doubt? B is absolutely correct. Okay, some of you have selected option A as well. Very good. Robin, Sarah, Shoaib, Farzana, Vikas, Sonia. Good. Let me know if any student has any doubt in this question. We can use V square minus, so I'm so sorry. You can use V square minus U square equals to 2AS also. You can use that. No problem. You can use that. Absolutely. You can use that. Clear. They were not talking about time. You can use V square also. Any more doubt? Clear? Can we move on to the next problem now? All right. Now let's see. Hopefully we have solved all the other questions of NLM. Moving on to the next one. This question. Please see. Come on, let's begin. I am going to explain this question to you, so don't worry. Pay attention. This question is saying a small ball of mass m is thrown upwards. So let's assume that this is ground, my dear friends. You have got a small ball of mass m, we have thrown it upwards, right, with some velocity u, and the ball experiences a resistive force m kV square. Resistive force m kV square, right? So see, we know that we have got acceleration due to gravity, but along with acceleration due to gravity, we have got one more force. So this is mg, and we have got now one more force, that is mkv square, right, where v is the speed. So my dear friends, now the net acceleration will become, it is acting in downward direction, it will become g plus k into v square. G plus k into v square. G plus k into v square, right? So they are saying that what is the maximum height attained by the ball? We cannot use equations of motion over here. Equations of motions are not valid. Equations of motions are not valid in these types of problem, because acceleration is not constant. Acceleration is variable. Acceleration is changing with speed. So whenever you cannot use equations of motion, please come back to old school methods. That means differentiation and integration, right? That means, my dear friends, differentiation and integration, simply write acceleration equals to dv by dt. But hold on, they are actually not talking about time. They are saying find out the maximum height attained by the ball. So for maximum height, instead of writing dv by dt, I will write it as v dv by dh. V dv by dh. A very important formula. We use this this form of acceleration whenever we want to relate velocity and displacement along with acceleration. This is a very, very important formula. A equals to V dV by dH. Usually you write it as V dV by dx, right? Right now I am not talking about x, I am talking about h. That's why I have written V dV by dH. Now this means that I am going to write V dV by dH is equals to negative times of G plus K into V square. Now, if you are new to this type of problem, let me explain how to solve. After this step, my dear friends, we separate the variables. We separate the similar variables to same sides. That means I am going to write V dV divided by, I need some space, I am going to write it over here. We are going to write V dV is divided by G plus K V square and equals to minus DH. Minus DH. We are going to write something like this. Okay. And after this, we are going to integrate it. We are going to integrate it. Right. Or what you can actually also do is you are going to then say that let's suppose then when height was 0, initial velocity was u, and when height is h, velocity will become 0. After this integration, you will get to your answer. Quickly write down in the chat box if you have got any doubt. Be quick, my dear friends. Any doubt till here? After this, you can assume g plus kv square to some constant. If you remember how to solve these types of problem, then that's best. But if no, then you can assume it to be some constant. Let's say we can use it as some constant p, or let's use it as c, right? And let's differentiate it with respect to dv, right? So if you are going to differentiate it with respect to dv, this will become 0, this will become 2kv, and this will become dc by dv. So dv will be equals to dc divided by 2kv. Or you can directly use natural log. There is also an identity. Okay, if you don't remember that identity, then I am explaining it to you. So you have got v dv divided by g plus kv square is c, and instead of dv, my dear friends, we are writing dc divided by 2kv. So v and v gets cancels out, and over here you have got integration of dh, and from 0 to h, and this is from 0 to from u to 0. Now integration of 1 upon c with respect to c is going to be natural log. So natural log answer is going to be correct. So either it's going to be B or C. Quickly let me know in the chat box if you have got any doubt, my dear friends. Be quick. According to me, answer C will be correct because we have got an extra 2 over here. We have got an extra 2 over here. Quickly write down in the chat box if you have got any doubt. Everything's clear? This is a nice problem. This is a nice problem. Pay attention. They can ask this question in NEET 2028, 2026 RE-NEET exam if they want to increase the level of the question. After this, all you need to do is you need to integrate. Clear? Done? Clear, my dear friends? If you have got any doubt, you can ask me. After this, you are going to integrate it, you will get to the correct answer. Moving on to the next one now. Come on. Now let's solve this question. Be quick. In this question, they are saying a block of mass 25 kg is pulled along a horizontal surface by a force at an angle of 45 degree with the horizontal. The friction coefficient between the block and the surface is 0.25. The block travels at a uniform velocity. The work done by the applied force during the displacement of 5 meter of the block is. Come on, let's solve this question. Be quick. A block of mass 25 gram is pulled along a horizontal surface at an angle of 45 degree with the horizontal. So we have started work per energy now. You have got a block like this, and there is a force acting on this block at an angle of 45 degree. At an angle of 45 degree. And this force is, we don't know what this force is, right? We don't know what this force is. Let's say this is F and this is 25 kg. And we have got also friction coefficient is 0.25. Done. So let's draw all the other forces. There will be mg, there will be mg, there will be F cos 45, there will be F sin 45, there will be friction force, right? So this is mg, this is F root 2, this is also F root 2, and this is mu times of normal reaction, and normal reaction is mg minus F root 2. The block travels at a uniform velocity. This is very important. This is very important. When they are saying that the block travels with uniform velocity, it means that net force will be 0. It means that net force will be 0. It means that net force will be 0. And if net force is 0, we are going to equate these two forces. That means mu mg minus mu F by root 2 is equals to F by root 2. We are going to equate these two forces, my dear friends. Clear? So I think we know each and every value. Mu is 1.1 by 4. Mg is 250 minus 1 by 4 F by root 2, or what I can do is I can write this as F by root 2 1 plus 1 by 4. So you can actually write 4, you can cancel out this 4 with this, and we can find out the value of F from here. Okay, we can get, and this is, by the way, this is 5, right? So this is going to be 50. So F will be 50 root 2. F is going to be 50 root 2. F is going to be 50 root 2. The work done in a displacement of 5 meter. So displacement is in this direction. So work done will be F root 2. So that means 50 root 2 divided by root 2 multiplied by 5 meter. So answer will be 250 joules. Answer will be, maybe we have taken the value of G as 10. If we'll take to 9.8, I think we'll get to the correct answer. We'll get to the correct answer, my dear friends. Let's check it again. Let's check it again. Let me see if we are going to. You guys tell me if you are getting the correct answer. 250 after taking 10. See, we have taken, if we are going to take that as 9.8, then we'll get to the correct answer. You will write down in the chat box. Be quick. Be quick. Let me know. For this question, friends, come on. Let me know. Correct, na? Clear? This is right. We have taken 10. They must have taken it as 9.8. No problem. Everything else is fine. If you have any doubt, you can ask me. Else I'll move on. Done. Done. All right. Moving on to the next one. A block of mass 10 kg starts sliding on a surface with an initial velocity of 9.8 meter per second. Here they are saying it as take g as 9.8, so we will take 9.8. Clear? Next, they are saying the coefficient of friction between the surface and the block is 0.5. The distance covered by the block before coming to rest is. All right. Clear. So it is sliding on a surface with an initial velocity of 9.8 and coefficient of friction between the block and this is okay, fine. Let's quickly solve it. So you have got a block like this and friction force will act in the backward direction. It has got certain initial velocity and initial velocity is of 9.8 meter per second. 9.8 meter per second. And friction force will be, by the way, I have to actually find out, this is mu m into g and acceleration due to this will be simply mu into g. So mu is 0.5 and g is 9.8. So they are saying the distance covered, right? So let's use v square equals to u square plus 2as. So v is 0, u is my dear friends 9.8, to acceleration is 0.5 into 9.8 into s. 9.8 gets cancels out, 2 times 0.5 is 1, s comes out to be 9.8 meter. B option is correct. Done? Clear? Any doubt in this question? Be quick. Be quick. I think we have completed almost 20-25 questions till now. And these are nice level problems. Yes, B is absolutely correct. If you have any doubt, do let me know. Else, I'll move on to the next one, my dear friends. All right, let's move on. Aja, you can also discuss your strategies if you have any doubt. Okay? If you are thinking that if you have any problem in preparing physics for your RE-NEET exam, you can ask me. You are asking about, sir, daily life timing. So see, the timing of live classes are being posted on this batch on the community section. I think one day before the live class. Okay? So you can actually please come on this channel and daily we have got either chemistry, biology or physics class, right? So today we have got physics class, next class will be on Saturday for physics, right? So you can actually catch the timing, you can get to know the timings and the day about the classes on the community section of this channel. Moving on to the next one. Come on. A uniform metal chain of mass m and length L. Okay, so we haven't done any pulley problem till now. So let's do one. A uniform metal chain of mass m and length L passes over a massless and a frictionless pulley. It is released from rest with a part of its length L is hanging on one side and rest of its length L minus L is hanging on the other side of the pulley at a certain point of time when small l is equals to capital L divided by x. The acceleration of the chain is g by 2. The value of x is. All right. Let's do this problem, my dear friends. You have got a chain which has got a total mass of m. Let me explain this problem to you. Total mass is m, total length is L. So mass per unit length will be m divided by L. They have said that at a certain point when small l is equals to L by x, when this is L by x, when this is L by x, right? Fine. So this length will be L minus L by x. Mass of this is going to be, kindly see, mass of this will be, small m will be L by x times m by L. That means it will be m by x. So this will be, my dear friends, m by x multiplied by g. m by x multiplied by g. Mass over here, I'm fine. Mass over here will be m by L multiplied by xl minus L upon x. I can cancel out this L. So I will get m by x times x minus 1. Over here I am getting mg by x, right? Clear? Obviously this is heavier, so this will go down. So net acceleration will be written something like this. Net acceleration will be written something like this. This force, that is m divided by x minus 1 times g minus m g divided by x whole divided by total mass, that is m. M gets cancels out and A net is coming out to be, they have said that A net is g by 2. So g by 2 is equals to g by x times x minus 1 minus g by x. So g can be also cancelled out. We can also cancel out g. So this will become x, this will become 2x minus 2 and minus 1. So this will become 3x and this will become 3. So x is coming out to be 1. Just a second. Just a second. See, my dear friends, if we have done any mistake, be quick. Be really, really quick. Have you done any mistake? Okay, just a second. You don't have to select it as L by X. Kya? Okay, fine. Okay. Just a second. No problem. No problem, my dear friends. No problem. Hold on. Actually, we have to find out the value of x. My bad. We have to find out the value of x. I have chosen the fraction to be x. Concept was absolutely correct, but we can't select x. We can't select x, my dear friends. We cannot select x. So what we are going to do is, when L is equals to L by x, right? Okay. So let's do one thing. Let's write this mass as m by L times x. Let's do something like this. Let's say this is actually equals to x and this will be L minus x. So this force will be m by L times L minus x times g. Concept is exactly the same. There is no change in concept. Still, A net will be equals to the net pulling force, which is m by L times L minus x times g minus m by L times x into g whole divided by total mass m. Now A net is given by g by 2. A net is given by g by 2 and this will become m by L minus x times g minus m by L x times g whole divided by m. M can be cancelled out, g can be cancelled out, right? G can be cancelled out and I can multiply this L2 to this side and I can multiply this 2 to this side. So this will become 2L minus 2x minus 2x. Now please see. Kindly see. See, my dear friends, now everything is clear. See, initially I have said, I have selected ki let's say this is L by X. That is wrong. Let's suppose that this is X part. This is X part, so this will automatically become L minus X. If this is X length and total length is L, kindly see, I am explaining it to you. Total length is L and I am saying this length is X, so this will become L minus X, right? This will become L minus X. Total downward force will be mass of this part of the length. So this is L minus X. Unit mass is M by L. So M by L multiplied by length. Similarly, M by L multiplied by length. Clear? Solve that, we'll get to our answer. I believe we'll get to our answer. This will become minus L and this will become minus 4x, and we want to find out x. So x will be L by 4. X will be L by 4. Clear? Now let me know if you have any doubt. We have got our answer, my dear friends. Answer is correct. 4 is absolutely correct. This is a very nice problem. You should practice questions like these. This is based on a very simple concept of pulley, and you all know these types of questions, my dear friend. Let's suppose we have got a pulley, it is attached over here. We have got two blocks, something like this. Clear? We have got two blocks. All of these ropes, strings are massless. Let's say this is M2, this is M1. So we simply write down the net acceleration as net force divided by total mass. So net force is M2G. Let's suppose M2 is greater than M1. M2G minus M1G divided by M1 plus M2. So exactly same thing I have done over here. Please see, A net is F net divided by M total. A net is F net. That means the mass of this part of the chain acting downwards. So mass is M divided by L times length of this part times G. So this is M2G. This is M1G. So M2G minus M1G divided by total mass M. And they have already told you what is A net. A net is G by 2. After that you can get to the answer. Clear? Quickly write down in the chat box if you have liked the explanation, if everything is good, write down in the chat box. Be quick. And then I'm going to move on. Then we will move on to the next one. Be quick. Any more doubt? Any more doubt, my dear friends? Clear? Clear? All right. Then we can move on to the next question. See, these questions are very nice problems. You are not going to see, there are very less channels where you can solve questions of this standard for your RE-NEET exam, right? Stop solving only NEET PYQs for your RE-NEET exam, because you might get a little shock in your final RE-NEET paper. NTA can actually set a slightly difficult exam, right? So this is the level of questions that we should actually go for. Moving on to the next one. A block of metal weighing 2 kg is resting on a frictionless plane. Fine. It is struck by a jet releasing water at a rate of 1 kg meter per second. So this is what I have been telling you, that they are going, whenever you are going to see a unit like this of 1 kg per second, that is mass rate. Dm by dt. Then the initial acceleration of the block is, okay, fine, at a rate of 10 meter per second. So this is very easy. So you simply have to write F is equals to V times dm by dt. So V is equals to 10 meter per second and dm by dt is equals to 1. So answer is 10, and acceleration will be 10 divided by mass, that is 2, which is 5 meter per second square. So one difficult, one easy, one difficult, one easy, right? Come on, let's move to the next one. Again, you have to use the concept of A net. A net will be net force divided by total mass. A net will be net force divided by total mass. A net is going to be net force divided by total mass. So let's draw the forces over here. You have got force acting in this direction, force acting in this direction. You have got tension, but I don't have any problem with that, right? This is, if this is T, then this is T. This is mg sine 30. Sine 30 is 1 by 2. This is mg, g is 10 into sine 60. Sine 60 is root 3 by 2. Friction is not there. Frictionless surface, right? So A net will be, kindly see, this is 5 meter, this is 5 Newton. This is of course 20 times root 3, so this is greater. So we are going to write 20 root 3 minus 5 divided by total mass. Total mass is 1 plus 4, that is 5. Cancel 4. So answer will be 4 root 3 minus 1. 4 root 3 minus 1. 4 root 3 minus 1. And friction is not there. Friction is not there, my dear friends, right? So 4 root 3 minus 1, that means option D is correct. Clear? Any more doubts? Robin, any doubt? Be quick. Let me know in the chat box. mg sine 60, mg sine 30, right? And we don't have any friction, so simply write this force minus this force divided by total mass. Moving on to the next one. Let's solve this question. Another problem. Clear? Good. A balloon of mass m is ascending with an acceleration a. You have got a balloon and it is moving up with an acceleration of a. It is moving up with an acceleration of a. Fine. If it is moving up with an acceleration of a, then let's figure some things out. See, it has got total mass m. Definitely mg is going to act downward. Mg is there, right? Mg is acting downward. And still, if it is going up with an acceleration of a, that means there must be some force which is providing this upward acceleration, and that is F. So initially we can write that F minus mg is equals to m into a. That means F is equals to m times of g plus a. This is the driving force because of which the balloon is accelerating upwards. Clear? And then they are saying what fraction of its mass should be dropped. What fraction of mass should be dropped? So let's suppose m mass is being dropped. M mass is being dropped. So if m mass is being dropped, now the new masses of the balloon is m minus m. Capital M minus small m. Capital M minus small m. This is the new mass. In that case, the acceleration becomes, the acceleration becomes 3a. The acceleration becomes 3a. You have not changed the driving force, so driving force will remain same, F, and downward force is changed, minus m multiplied by g, and equals to m minus m multiplied by 3 times of a. But what they want us to find, what fraction? They want us to find out small m. They want us to find out small m, right? Clear? So let's substitute the value of this capital F over here. So we are going to get m g plus m A minus mg plus mg is equals to 3am minus 3am. So mg and mg gets cancels out. And my dear friends, please note that I want to find out small m, right? So bring this small m over here. So 3am plus mg is equals to 3am minus ma. So you will be left with m times 3a plus g is equals to, that will be 2am. So small m will be 2am divided by g plus 3a. Nice problem. Nice problem. Clear? Quickly write down in the chat box. Be quick. See, these types of concepts are new. It can be new for you, right? Because if you have solved NEET PYQ, then write down in the chat box if you have solved questions like these. Robin, Henry, everyone, Gaurav, Saksham, everything's clear with this question. Please remember that this is the driving force. This is because of the engine of the hot air balloon, right? Engine of that thing because of which it is accelerating. So we are not changing anything in that. Buoyant force is not over here. But we are going to ignore things like buoyant force as long as they have not mentioned it. See, they have not talked about volume of this. They have not talked about the air around it. They have not talked about the density of those things. So we are not going to assume buoyant force. Right now, this is your common sense that okay, if you are going to drop something down, that will not change the driving force, but that will change the mg force. Because of that, net acceleration will increase in upward direction. This is a very nice problem. Okay, moving on to the next question. You guys can see this is the beauty of these live lectures. We could have recorded these and we could have simply uploaded it. Somebody has asked me about buoyant force. This is a very good doubt, that what about buoyant force? We don't have to assume it. Why? Because they have not mentioned anything about that. Clear? Moving on to the next one. My dear friends. Let's move. This is the next problem. Come on. Let's solve. As shown in the figure, a 70 kilogram garden roller is pushed with a force of 200 Newton at an angle of 30 degree with the horizontal normal reaction. So this is a normal question. Nothing too difficult about this. Be quick. Nothing too difficult about this, my dear friends. Solve this question. Be quick. Shall we move on? This is a force. Okay. We can also draw a force like this. This is acting at an angle of 30 degree. This is 30 degree. And this force is of 200 Newton. This is 200 sine 30. This is 200 cos 30. I don't have to do, we don't have to do anything with that, right? We don't have to do anything with that. Along with this, you also have got mg. So plus mg. So mg is 700 Newton. Clear? So normal reaction will be simply the sum of these two things. So that means 100 plus 700, that is 800. So this is an easy question. 800 Newton is the correct answer. 800 Newton is the correct answer. Clear? Any doubt? Any doubt, my dear friends? Be quick. Clear? Somebody has said B. So please kindly check. All right, moving on to the next one. Moving on to the next one. Let's see this question. Let's see this one. Question is saying, let's read it together. It's an easy one, don't worry. Consider two blocks A and B of masses 10 kg and 5 kg kept on a frictionless table. Table is frictionless. The block A moves with a constant speed of 3 meter per second towards block B kept at rest. A spring with spring constant of 3000 Newton per meter is attached with the block B as shown in the figure. After the collision, suppose the blocks A and B move along, A and B along with the spring in constant compression state move together, then the compression in the spring is. Okay, we have to find out the compression. We have to find out the compression. Can I draw the diagram over here? Because I don't have much space. Let me explain this question to you. Okay, I'll give you some time, then I'll explain. Solve, my dear friends. Block is coming. Now see, I have made a copy of this, so do not get worried. I am removing this question from here. Right, and I am solving. First of all, please see that it is moving with some velocity v, and that velocity is 3 meter per second. This is 3 meter per second. All right. It will move. It will start to compress this spring. Now please understand what's going to happen. When it will start to compress the spring, right? When it will start to compress the spring, there will be a point. There will be a point when something like this will happen. You have got a spring over here and you have got a block and you have got another block over here, and it will start to compress it. It will start to compress it, and the spring will get compressed and spring will apply forces along this direction. Please understand, I am explaining you the mechanism, okay? Spring forces are acting like this. So because of these spring forces, the velocity of this block B is increasing. The velocity of this block A is decreasing. Initially, this is 0. Initially, this is 3 meter per second. So when spring will get compressed, the spring will actually apply force in this direction, in opposite direction, right? And when it will apply force in opposite direction, this spring force will cause retardation for block A. So its speed will start to decrease from 3 meter per second, and it will start, and this force will start to increase the velocity of B. At a particular point, at a particular point, my dear friends, what will happen is that they will start to move with a constant velocity. They will start to move with a common velocity. So all of them are going to move with a common velocity. At that point, this compression is maximum. You have to remember this. At this point, this compression is maximum. All right. At this point, this compression is maximum. So initially this will start to decrease, this will start to increase. At a point they will become same, and at that point this will become maximum. Now how to find out? First we are going to find out that common velocity. So we are going to start with this. Let's say this is our final state and let's say this is our initial state. So first thing first, let's apply conservation of linear momentum. Let's apply conservation of linear momentum. So we are going to write mass 10 into 3, that's it. this is at rest, equals to mass 10 plus 5 15 multiplied by common velocity. This will become 5, this will become 2. That means common velocity comes out to be 2 meter per second. Common velocity comes out to be 2 meter per second. So they are moving with 2 meter per second of velocity. Now again, let's apply one more law, one more conservation, that is conservation of mechanical energy. Next is conservation of mechanical energy. This is the initial point, this is the final point. We are going to write, initially we have got only kinetic energy, that is half mass into V square is equals to, then we have got half mass of both of these blocks, that means 10 and 5 I believe. So half m V square plus half k x square, and k is 3000 times x square. Half can be cancelled out, right? This will become 90, this will become 60, this will become, this is 3000 times x square. So x square will become 30 divided by 3000. So this will become 1 upon 100. That means x will become 0.1 meter. 0.1 meter is correct answer. Clear? Done? Be quick. Let me know in the chat box. 0.1 meter is correct answer. This is your entire problem, entire question. C is the correct answer. C is the correct answer. Along with this question, I have explained each and every concept related with this concept. Initially, it will strike, right? Spring force will act in either directions. Sorry, spring force will act in both directions, and because of those spring forces, velocities will change. At a point, they will achieve a common velocity. This is our final state, my dear friends. Whenever you have got a question like this is going to be your final state. And now you don't have to look for any intermediate state. You just pick the initial state when the block was not colliding, right? And apply conservation of linear momentum and conservation of mechanical energy, these two things. All right, clear? Moving on to the next one if you don't have any doubt. Okay, let's move on to the next question. This is our next question. This question is saying a particle experiences a variable force F equals to 4x I cap plus 3y square j cap in a horizontal xy plane. Assume distance in meters and force in Newton. Okay, I am also starting poll for this. 60 seconds, let's start. And then they are saying particle moves from point 1, 2 to 2, 3 in the xy plane. In the xy plane. Then kinetic energy changes by. Concept is, let me tell you the concept. Concept is work energy theorem. Work energy theorem. Work energy theorem says that work done by net force is equals to change in kinetic energy. Work done by net force is equals to change in kinetic energy, right? So they are talking about change in kinetic energy. So let's find out the net work done. Let's find out the net work done. Got it? Because change in kinetic energy is equals to net work done. So net work done will be simply integration of fx dot dx from 1 to 2 plus fy dy from 2 to 3, and then when you are going to integrate 4x with respect to x square, you are going to get 4x square by 2, 1 2, when you're going to differentiate 3y square, you will get 3y square divided by 3, sorry, 3y cube divided by 3. From 2 to 3, this will become 2, this 3 will get cancelled out. Square of 2 is 4, 4 minus 1 plus 3, and this is I believe 27 minus 8. Come on, let me know the answer, what answer we are getting from this one. So whatever, acha, this 3 is also getting cancelled out, so we don't have 3 over here, right? So this is 6, this is 6, and this is 19. That means 25 joule is the correct answer. 25 joule is the correct answer. Clear? Any more doubt? Be quick. 25 joule is the correct answer, my dear friends. Can we move on to the next one now? Let me know. All right. Let's see this question. Conservation of mechanical energy. Question is saying a simple pendulum of length 1 meter. A simple pendulum of length 1 meter has a wooden bob of mass 1 kg. Has a wooden bob of mass 1 kg. It is struck by a bullet of mass 10 to the power minus 2 kg. 10 to the power minus 2 kg moving with a speed of 2 into 10 to the power minus 2 meter per second. The bullet gets embedded into the bob, the height to which the bob rises before its swinging back is. Alright. So you have got a pendulum and a block is attached to this string, right? A wooden bob of mass 1 kg. So this is of 1 kg. And then a bullet is coming, and bullet's mass is 10 to the power minus 2 kilogram. And its speed is 2 into 10 to the power 2 meter per second. And it gets embedded in the bob. This means that they are saying that it's an inelastic collision. It's an inelastic collision. So the first thing will be conservation of linear momentum. Conservation of linear momentum. Which means that we are going to simply say mass of the bullet 10 to the power minus 2 multiplied by V 10 to the power 2 is equals to mass of block plus mass of bullet times common velocity. So this gets cancels out. My dear friends, I can write 1 plus 10 to the power minus 2 can be written as V, can be written as 1. So this will be 2 meter per second. So we are assuming that it is moving with 2 meter per second, right? So this thing will move with 2 meter per second. And then what height will this achieve? Let's find that out. Let's say this height is h. So we are going to simply say half m. I have ignored the mass of the bullet because it is 0.01 kilogram. I have ignored 0.01 kilogram in front of 1 kilogram, right? So half m into v square, and v is, by the way, 2. So square of 2 is equals to mg into h. So this gets cancels out. So h will be equals to 2 divided by 10 or 0.2 meter. So this will be nearly around 0.2 meter. Nearly around 0.2 meter, my dear friends. If you are going to assume the mass also, you must get to the around same answer. You must get around same answer. Please see. Please see, my dear friends. Any more doubt? Clear? Clear? Can we move on to the next one? All right. Great. Okay. This is a new problem, a new type of a problem. Okay. New type of a problem. A wedge of mass capital M equals to 4m lies on a frictionless plane. A particle of mass small m approaches the wedge with a speed v. There is no friction between the particle and the plane or between the particle and the wedge. The maximum height climbed by the particle on the wedge is given by. See, wedge is a different thing. Okay. Whenever you are going to see a wedge, please note that this can move. So we have got a situation somewhat like this. Kindly read the question. By that time I am drawing diagram for you. You have got a wedge like this. You have got a wedge somewhat like this. Surfaces are frictionless, no doubt about it. But what's going to happen when this block will actually strike this wedge, right? This is moving with a speed of v. This is moving with speed v. It has got mass m. It has got mass 4m. So this block, this wedge will also start to move with some velocity. It will also acquire some velocity, and this at that point, let's suppose it reaches at a certain height and we want to find out that height. So first of all, we'll find out that velocity. So we are going to use again conservation of linear momentum. And we are going to write m into v is equals to m plus 4m multiplied by v dash, that means, or vw, velocity of wedge. So velocity of wedge will become, m will certainly gets cancelled out, it will become v by 5. V by 5. That means it will acquire a velocity of v by 5 over because of this. V by 5 because of this. And it will keep on moving, right? And now between this point and this point, let's apply conservation of mechanical energy. So we are going to write in initial energy of this system is half m v square is equals to, then you have got half 4m and m is 5m, and then v square by 25 and plus mgh. M can get cancelled out, 2 and I'll write 2 over here, this will become 5. So this will become v square minus v square by 5 is equals to 2g into h. And I think instead of g also, fine, it's fine. So we have got, this will become 4v square by 5 is equals to 2g into h. So this will become 2v square by 5. So h will become 2v square by 5g. 2v square by 5g. 2v square by 5g, option B is correct. Let me know, my dear friends, you like this question? This is again a new type of a problem. You have not seen these questions in your NEET PYQ. You might not have seen these questions in your notes also. So kindly note, you know conservation of linear momentum, you know conservation of mechanical energy, but sometimes we don't solve problems related with wedges. Is there any doubt? Be quick. Let me know in the chat box. let me know in the chat box. Any doubt? Henry, Robin, Jay, any more doubt? Clear? Please ask. If you have doubt, Harsh, please ask me. Please ask if you have any doubt. Clear? I mean, there is always somebody in the chat. I mean, there are different people, but there is always one student who is always asking about some girl ki kaisi ho, how are you, kahan rehti ho. Whenever I see chat. So, nice. Consistency. Let's move on to the next one now. Let's move on to the next question, my dear friends. Now, I don't have any problem with that, but I can't really understand why you guys actually choose my chat box for all of these things. I mean, see Jay Singh, any romantic girl. Okay, let's come back to mechanics. A uniform cable of mass capital M and length capital L is placed on a horizontal surface such that its 1/nth part is hanging below the edge of the surface. This is a typical traditional type of a problem, right? I mean, general question, standard question, I can say. So we have got a table, and then you have got a chain, and its 1/nth part is hanging. Kindly see that its 1/nth part, its 1/nth part is hanging, right? So mass per unit length is m by L. Mass per unit length is m by L. So this much length will have mass L by N times m by L. That means simply m by N. M by N. And please understand one more thing. The total length is L, so this length will be L by N. So the center of gravity will be at, this is going to be m dash into g. The center of gravity will be at this point. The center of gravity will be at this point. This length will be L by 2n. Half of L by n. Half of L by n. Right? L by 2n. Clear? Half of L by n. Right? So we are going to simply write down the work done by mg force. Let's write down the magnitude of that. So that will be mg m dash into g times L by 2n, because if you want to lift this chain above, if you want to lift this chain upward, then you want to actually move this center of gravity from this point to this point. Clear? We, instead of assuming that we have got this entire chain, we are assuming that this entire mass m dash is at this point, at the center of mass of this part. Right? So we want to lift this m dash mass from here to here. So this length will be half of this length. This length is L by N, so this length will be L by 2n. So that means m dash g times L by 2n. L by 2n. This is n. So m dash is m by L. M dash is m by n. G L divided by 2n. So it would be mgl divided by 2n square. mgl divided by 2n square. mgl divided by 2n square. All right. mgl divided by 2n square. Be quick. Let me know if you have any doubt. Clear? All right. Can we move on to the next one? Next question is saying a ball having a kinetic energy Ke is projected at an angle of 60 degree from the horizontal. What will be the kinetic energy? What will be the kinetic energy of the ball at the highest point? So again, this is an easier question. If you are going to project a particle from ground and its velocity is, let's suppose its velocity is u and this is 60 degree. So at the highest point only the horizontal component will remain, that is u cos 60, that means u by 2. So at initially you have got half m u square and finally we have got half m u square by 4, that means this is 1/4 of kinetic energy. D is correct. D is correct. Clear? D is absolutely correct. All right. D is absolutely correct. Moving on to the next one, vertical circular motion. Come on, let's solve this question. I am opening the poll for this question. Oh ho ho. You guys, can you guys help me? I think I have given you poll for, I don't know, maybe for the wedge one. I think before that. I think it's C. Let's check. Yes. Correct. 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 Let's start this question. 60 seconds is sufficient for this problem. If you know the results for vertical circular motion. If you know the vertical circular motion's result, then 60 seconds is more than sufficient. Solve. A bob of mass m is suspended by a light string of length L. It is imparted by a minimum horizontal velocity at the lowest point A such that it just completes half circle reaching the topmost position B. The ratio of kinetic energies of A and B. Ratio of kinetic energy A and B. See, minimum energy that we can actually give this particle so that it completes the vertical circular motion is root 5 GL. And if you are going to give this root 5 GL, it will automatically become root GL. And kinetic energy will become, the ratio of kinetic energy will become VA square, that means 5 GL divided by GL, that means 5:1. 5:1. Clear? 5:1 is the correct answer. Option D. Some of you have also said 2:5. How come? Any doubt in this question? Please let me know if you have any doubt. 5:1 is correct. Many of you have selected option B. Please note, this is the minimum velocity. If you are going to give root 5 GL, then the particle will complete the circle. For this velocity, this becomes root 3 GL and this becomes root GL. Right? Inside the root, there is a there's a we actually decrease the number by 2 values, right? So from 5 it becomes 3, from 3 it becomes 1. All right, let's start this problem. Let's start this problem. If the kinetic energy of a moving body, if the kinetic energy, pole is on, please attempt the pole. If the kinetic energy of the moving body becomes 4 times, if the kinetic energy of the moving body becomes 4 times its initial kinetic energy, then the percentage change, in its momentum is, first of all, please know that we can write down, instead of momentum, we can write down under root 2 mke. We can write down 2 mke. And now they are saying that kinetic energy is becoming 4 times. Kinetic energy is becoming 4 times, right? If kinetic energy is becoming 4 times, the momentum will become 2 times of initial momentum. Please understand, 2m, and this will become 4 ke, and that will become 2 times of initial momentum. And if you want to find out the increase in momentum, this is not 200%, but this is 100%. Whenever you have got doubts, simply do it by this. Delta P upon P in percentage is going to be final momentum minus initial momentum divided by initial momentum multiplied by 100. So this is 100% increase. Clear? Easy? This is going to be 100% of increase. Option A. Very good. Let's solve this question. Easy, difficult, right? Let's solve this problem. A particle is dropped from height h equals to 5r, and moves as shown in the figure. Calculate the force with which it pushed the track when it reaches at point C. When it reaches the point C of circular track. When it reaches the point C of circular track. This is point A, this is point B, this is point C, this is point D. Let's start. Quick. Come on. Friends, first of all, we have to use conservation of mechanical energy, right? So let's go step by step. We are going to first we apply conservation of mechanical energy between this point and this point. Right? So at this point it has got total energy is mgh, and instead of h I am going to write mg into 5r, and this is equals to half m into VA square. M can be cancelled out. This will become 10. That means VA square will become 10 GR. VA will become 10 GR. VA, this is VA. This will become 10 GR. Now we are going to apply conservation of conservation of mechanical energy between point A and point C. Right? And we are going to write, at this point we have got total energy is kinetic energy half m VA square, that means 10 GR, and at that point let's suppose it has got velocity VC, we want to find that out. So half m VC square plus potential energy will be, this is actually they are saying that radius of track is r, so this is going to become 2r. So this will be mg into 2 into r. So m gets cancels out, right? I can also cancel this 2, and I'll write 2 over here as well. And please remember, I want to find out VC square. So VC square will be equals to 10 GR, and this is 4 GR. So this will become 6 GR. This will become 6 GR. Hopefully everything is clear till this point, right? This is 10 GR, that was 4 GR, this is 6 GR. So VC is clear. At this point, my dear friends, let's draw a free body diagram. You have got mg acting downward. You have got mg acting downward. You have got mv square by r acting in upward direction, right? And you have got normal reaction in upward direction. I mean, the force with which it is pushing the track. So this is mg. This is mg. This is mvc square by r, right? Clear? So the normal reaction will be, because that's what they are saying, calculate the force with which it pushed the track. So it pushes the track with mg minus mvc square by r. So it's going to be mg minus mvc square is 6gr divided by r. R and R gets cancels out, and obviously my dear friends, this one is mg will be less, right, as you can see. So this is going to be 5 mg. A option is absolutely correct. A option is absolutely correct. Let me know in the chat box. Be quick. Nice problem. So we have to apply conservation of mechanical energy from this point to this point. Then we have to apply the conservation of mechanical energy from this point to this point. Clear? Is everything clear? Fine. Be quick. Let me know in the chat box. Any more doubt? Any more doubt? Option A is absolutely correct. Clear? Nice problem. Please understand, if it is actually moving along the track, obviously it will apply the force in this direction. If let's suppose net force is more in this direction, if mg is more, then it will fall from track clearly. So obviously mv square by r, mvc square by r will be more than mg, right? And normal reaction will act in normal reaction will be applied by the track on the uh, on the car in downward direction. Clear? Sorted? Please understand the dynamics clearly, right? All right, my dear friends, very good. Let's move on. Let's move to the next question. Let's move to the next problem. A block of mass m is released from rest at the top of a frictionless incline of height h and theta and angle theta. It then slides onto a horizontal surface and collides with a spring of constant k. Find the maximum compression in the spring. You have to find the maximum compression in the spring. Let's begin. I'm going to give you poll for this question. 90 seconds, let's start. Let's start. A block of mass m is released from rest at the top of a frictionless. See, all of these questions are for work energy theorem. So now let me know in the chat box these many questions. At the very start I have said ki after this class your Newton laws of motion and your work power energy will be almost over. After this you only have to solve some questions from your mock exams, and what you are going to observe is those questions will be definitely of lesser difficulty level than these questions, right? Let me know. We are going to solve some couple of questions more. Again, you don't have to think about the intermediate stages, right? All you can do is, this is your initial point, this is the initial state of the system, and then they are saying that we have to find out the maximum compression. At maximum compression, of course, it will come at rest. So this is your final state. So simply write down initial energy is mgh, this is h. So initial energy is mgh, and that will be simply equals to half kx square. And this is your maximum compression. That's it. So maximum compression will be 2 mgh divided by k and under root of this. Option B is correct. Very easy question. As compared to the previous problem, this is very easy. Very good. Some of you have said A, but A is not correct. Please see, because of this 2, you are going to get 2 mgh, right? Let's solve this problem. Under the action of a force, a 2 kilogram body moves such that its position x as a function of time t is given by x equals to t square by 3, where x is in meter and t is in second. The work done by the force in first 2 seconds is, alright, in first 2 seconds. Again they are talking about work done. And whenever, see, I have told you this again and again, that whenever they are going to talk about work done, simply write that net work done can be written as change in kinetic energy. Is that correct? And they have also said that x is equals to t square by 3. So that means v can be written as dx by dt. So this will become 2t by 3. Now 2t by 3 basically means that initial velocity will be 0 and final velocity will be, after 2 seconds it will be 2 times 2 divided by 3. That means 4 by 3. 4 by 3 meter per second. 4 by 3 meter per second. So change in kinetic energy will be half m into v square 16 by 9. So 16 by 9 joule is the correct answer. 16 by 9 joule is the correct answer. D is correct. Alright, D is absolutely correct. Alright, let me know in the chat box if you have any doubt. Moving on to the next one. A body which is moving with 10 meter per second is sliding up on a rough inclined plane having an inclination of 30 degree. Find the height up to which it can go if coefficient of friction of the inclined surface is 0.1. Come on, let's do this problem. My dear friends, you have got a surface having an inclination of 30 degree, and then they are saying that a body is moving up with a speed of 10 meter per second and coefficient of friction given for this surface is 0.1. Find out the net acceleration, right? Find out the net acceleration. Mg sine theta will act downwards and friction force will also act downwards. So g sine 30 and mu g cos 30. Is that correct, friends? That means net acceleration will be mu, or I can take g common, right? 0.1 times 10 times root 3 by 2 plus 10 times 1 by 2. This gets cancels out and you can actually write something like this if you want. And then you can use v square is equals to u square plus 2a into s. V is 0, u is 10, that means 100. This is 2 times 10 plus root 3 divided by 2. This is s, 2 and 2 gets cancels out, and let's please find out 100 divided by 10 plus 1.7, right? So 100 divided is 10, so it is slightly less than 10. Find out the correct answer for this one, my dear friends. Be quick. Find out the correct answer for this one. This is actually hmm. Please find whatever the answer is. Find the height up to which it is going. Acha. Okay, I'm sorry. They don't want to find out the distance. I'm sorry. They don't want us to find out the distance. They want us to find out the height. Yeah, so if they want us to find out the height, then why we are doing this? Sorry. I have read the question incorrectly. They are saying find the height up to which it can go. Find the height up to which it can go. Okay, clear. Fine, we can use this S for that also. No problem. So what we are going to do is, a body is moving with 10 meter per second is a body which is moving with is sliding up on a rough inclined plane having an inclination of 30 degree. Fine. If the coefficient of friction is 0.1, fine. So what they are trying to say is that let's suppose the block has reached over here and V is actually equals to 0, then they want us to find out this height, right? So use work energy theorem after finding out this S. Use work energy theorem. Work done by mg plus work done by friction force is equals to change in kinetic energy, right? So we can actually find out this distance. We can find out this distance, my dear friends. Let's say this distance is d, right? This distance is d. So this is going to be minus mg times h. This is going to minus mu mg cos 30 times d, and this is going to be minus half m v square. After this you will get to your answer, and this s is over here. This s is actually equals to d. Clear? Write down in the chat box. Sorted? Now you will be able to do. They were talking about height, my dear friends. They were not talking about this distance. They are talking about height. So you will have to apply work energy theorem again, right? Let me tell you, work energy theorem is basically net work done is equals to change in kinetic energy. Now this includes each and every force. Work done by conservative force, work done by external force, work done by non-conservative force, work done by pseudo force. All of these is equals to change in kinetic energy. And sometimes we can write, instead of this, we can also write down it as minus times of change in potential energy. Right? Hopefully this is clear. Clear? Sorted? All right. So in this question, they are saying that an object of mass 5 kg falls from rest through a vertical distance of 20 meter. So they are saying that an object of 5 kg falls from a distance of 20 meter, right? And then fine. And then the work done by air resistances, and it reaches the ground with a velocity of 10 meter per second. Again, see, I'll again tell you the same thing. Net work done is equals to change in kinetic energy. That means work done by mg, work done by air resistance is equals to final energy is half m v square. Initial was 0. Work done by mg will be mg multiplied by 20. Right? It's positive work done. Work done by air resistance will be negative, and that's what we need to find out. if you are going to put a plus sign, you will automatically get negative. So half mass is 5 into 100. This will become 50, this will become 250, and this will again become 50, isn't it? This will become 50, so this will become 1000. So here will become minus 1000 plus 250. So it has to come negative. Sorted, my dear friends? Any more doubt? Clear? All right. So I think we have finished sufficient amount of questions. Now in next class we are going to talk about, Acha, I've got one more problem. This was from one of the mock exams, right? Although we can solve these questions in SHM also, but let's have a look at this. Let's have a quick glance. A uniform spring of force constant K is cut into 3 equal parts. Is cut into 3 equal pieces. That means you have got a spring and then you are cutting it in 3 equal pieces. 3 equal pieces. So this is L by 3, L by 3, L by 3. Please remember that when you are going to cut them, their spring constant will become 3 times 3K, 3K and 3K. Note this point. And if you want to understand how this thing works, please remember that if you have got 3 different springs of spring constant 3K, 3K and 3K, and if you are going to join them in series, you are going to get this one big spring, right? And the spring constant will become 1 upon 3K, 1 upon 3K, 1 upon 3K. I'm talking about K equivalent. So this is how you can remember whenever you have got a spring, just cut, if they are saying it to cut it in equal pieces, spring constant will increase. And then they are saying that these are connected side by side in parallel, and this entire combination is connected in series with the third piece. That means you have got one spring like this, you have got another spring like this, and you have got third spring like this. So this is 3K, this is 3K and this is 3K. Now parallel combination, this means that this is 6K and this is 3K. So finally the K equivalent will be 6K multiplied by 3K divided by 9K. K and K gets cancels out, this becomes 3, this becomes 2, that means answer will be 2K. Answer is going to be 2K, my dear friends. Class timings. For class timings, let me, I have already told you that please watch this channel regularly. You are going to see see on the community sections when we are going to have our next class. All right, clear? Done? Everything's okay with this problem? Quickly let me know in the chat box. So after this, now we are going to start rotational motion and center of mass in our next class. These 2 chapters are over. I am pretty confident if you are going to solve these levels of questions, it will be good enough for you. After this, you can complete your NEET PYQs. You will be good enough for giving your regular mock exams. All right, clear? So I am going to see you in next class with center of mass and rotational motion. Okay, bye bye. Thank you so much. Bye. Take care.